Hi, my name is Zachary Wilson, and since the fall of 2020 into this summer of 2021, I've been working on developing liquid crystal thin films for application in solar cells. To give some background to this project, due to climate change and increasing energy usage, there comes a need for clean, renewable, and inexpensive energy, such as solar. Silicon solar cells are currently one of the most commercially available and efficient solar cells, but are expensive manufacturing. Organic solar cells present another possibility in photovoltaics since they are inexpensive manufacturing, they are less difficult in fabrication, such as thin films and printing, and are highly customizable. But the problem with organic solar cells is they are usually low efficiency due to their poor crystallinity, which is directly correlated to poor charge transferability. The Cone Lab has synthesized a liquid crystal polymer in this research, and this project seeks to develop thin films of this polymer for characterization and determine the feasibility in solar cells. In prior work, it's been shown that thin films of this polymer doped with tetrabutyl ammonium halides, such as fluoride, bromide, and iodide, can have an optical band gap range of 1.3 to 2.1 electron volts. And substrates coated with OTS prior to polymer coating and this polymer solution doped with TBA bromide gave the best ordering and uniformity thus far in the project. In the experimental design of this project, first comes the liquid crystal polymer synthesis and purification, going to the solution prep. In the separate step comes the substrate cleaning and surfactant coating. Then it goes into coating two different coating methods that can be used throughout this project, which is spin coating and drop casting, and then goes on to a full analysis of its characteristics. Results of the summer 2021 research showed that on the synthesis purification side of things, the synthesis of the polymer did not scale up well to produce a significant product yield. There was also difficulty in purifying the product, but on the thin film development side, it was discovered that only substrates cleaned with boiling isopropanol were able to have a sufficient wettability with THF or any other organic solvents or the polymer solution to be able to be coated evenly. As seen in image series 1, the polymer solution actually changes color when it's doped with TBA bromide. It's also shown in image series 1 that the films that were produced over the summer will change their order and organization or uniformity based on the heating process. Image series 2 shows a substrate that was not clean with isopropanol, but clean with different organic solvents. After it was coated with OTS, and then spin coated with the polymer solution, it did not have a good wettability, a sufficient wettability, producing only spots on the substrate. And after being dried, it showed this porous structure of the drop as seen here. Some conclusions in the synthesis and purification side of things. There was difficulty scaling up the reaction and purification, but there's a current investigation to options such as changing reaction conditions and thoroughly drying reagents before use. It was found in film development that the ideal technique for cleaning the substrates was with boiling isopropanol. And it was also found that thin films are extremely sensitive to the initial substrate surface, the surfactant coating, the coating solution in general, the coating technique, and temperature. There was difficulty fabricating continuous films, but with continued research, it's believed that a continuous thin film will be achieved by investigating each one of these factors. It's also planned that there would be characterization of these uniform and ordered films once they are achieved. I would like to thank the NJ Space Grant Consortium for awarding me this grant to continue research over the summer. Stockton University for allocating the resources and space to do the research. My mentors, Dr. Pamela Cohn and Dr. Woo-Sik Kee, for guiding and supporting me through this experience, and my past and current lab partners, Chengwan An and Mark Tell. And here are my references for the presentation. Thank you.